Hello everybody and welcome to another YouTube video. So in today's video, I'm going to be teaching you the basics of Go while applying everything that we learned directly into a project. So rather than sitting through 20 or 30 minutes of theory and then working on something, I'm going to teach you a very basic concept. We're going to immediately apply that concept right into our project, and every new concept that we learn is going to be kind of like the next aspect of the project. So this is going to be a learn by doing tutorial. I find this kind of the most engaging and fun way to actually learn a new language, and I will mention here that this tutorial is designed for beginners. So whether you've never written a line of code before or you're coming from another programming language, that's completely fine. I think you're really going to enjoy the Go programming language. In fact, it's one of my favorite languages, and I'm going to show you everything you need to know, assuming zero experience in this language. Last thing I will mention is that if you are a beginner or intermediate programmer, you may want to check out my new product, Programming Expert. This is something I've been working on for about 6 months with the Algo Expert team. We just released it last week, and this is an awesome platform to learn to code and teaches you pretty much everything you need to know to get up to a software engineer level in programming. Anyways, you can check that out from the link in the description, programmingexpert.io. Enough of that, let's go ahead and get into Go programming. Alright, so I'm here on the Go website homepage, and I just want to give you a quick introduction to this language before we dive into the code. So Go, otherwise known as Golang, is actually a pretty new programming language that was invented or created in 2012. Now, it was made by 3 employees at Google to kind of fix some of the problems that they were having with their standard languages or their official languages. Now, back at that time in Google, the official languages they used were Python, C++, Java, and most likely JavaScript and a few other languages. And the issue is that working in something like C++ or Java is very time-consuming, it's not very efficient, but you do get a ton of speed and performance benefits from those languages. Then on the other hand, you have Python, which is very quick to develop in, but is super slow, even though it has very simple syntax. So the developers at Google said, hey, we need something that's kind of going to bridge the gap between these languages and give us something that is very quick and easy to write in, but still has high performance. So that is kind of why Go was created. And so you're going to see when we start looking at this, that Golang is a very simple language. The syntax is very easy to understand. It's actually very similar to Python, but there's a ton of performance benefits. Golang is actually a compiled language, and it's very fast to compile and to run. Now, Golang is also a strongly and statically typed language, which makes it great for working on larger projects. Now, the main use cases of Go is pretty much on server-side applications, so writing stuff like APIs, website backends, any type of performance-heavy applications, and especially multi-threaded applications as well because of the concurrency support. Now, I'm sure this probably means nothing to most of you because you're probably beginner programmers if you're watching this, but I just wanted to give you a very quick introduction and talk about the main benefits of Go and why it was actually created. Alright, so now that we've talked about that, I can run you through the environment setup steps for Go. So what we're going to do is go to the download page for Go, which is right here. I'll leave a link to it in the description. You're just going to click on the appropriate operating system, so Linux, Mac, or Windows. You can run through the steps right here if you want, but really all you need to do is just click the download link that will be up here, again for Linux, Mac, or Windows. Double-click the installer, run through it. It should install and set up Go for you. And then what we can do is download our text editor or code editor, which is going to be Visual Studio Code. So downloading Go is one thing, but we actually need a place to be able to write our Go code in, and for this tutorial, I'm going to use VSCode. Now, you don't have to use this. If you have your own code editor or text editor and you understand how that works, you can use your own. However, if you are new to programming or you're new to Go, then I would recommend that you just download VSCode because then everything I do in this video will apply for you as well. Anyways, I'll leave a link to this in the description. You should be able to just click this button and it will download the appropriate version for your operating system. Again, run through the installer and then open up Visual Studio Code and we'll start working with Go. Alright, so at this point in time, I'm going to assume you successfully installed Go and VS Code. The installers are very straightforward. You just need to run through them and click next as many times as is required. And now I'm going to ask that you open up VS Code or whatever your text editor is. So now I'm inside of VS Code, and mine will probably look a little bit different from what yours looks like. The first thing we want to do inside of here is we want to open up some type of folder where we're going to write our Go code. So what I've done is I've gone to File, I've clicked on open folder right here, and then I've selected a folder where I have this notes.txt file, which is just my notes for this video. Now you can open up any folder that you'd like. You can also make a new folder by just clicking on new folder like that, and then making the new folder. Now I'm going to delete that because I don't need the new folder, and I don't want to open up a different one. Anyways, just open up a folder, and then you should see on the left-hand side of your screen here that you have kind of a file view, and you can see the folder is open. Now you won't have anything inside of your folder, so what you can do is make a new file by clicking this button right here and making something like tutorial.go. Now, all of our Go files are going to end in .go, so any code that we want to write that's Go code needs to go inside of a .go file. Anyways, for now, I'm going to call mine tutorial. You can call yours whatever you'd like. Just make sure it's one word, because if you add any spaces, then this might be a little bit different or kind of mess you up for the future steps in this video. So for now, I'm going with tutorial.go. As soon as I make that file, we should see that it opens that up in our editor here, and this is where we can start writing our code. However, before we can do that, we need to install an extension for VSCode. So VSCode comes very lightweight. It doesn't come with a lot of features. You actually install the features as you need them. So if you look on the left-hand side here, we can go to this extensions pane. It's kind of this grid with a square coming out. And what I can do is search Go in the marketplace search, which is at the top of this window. So I'm going to search Go. Notice Go shows up right here. And then what I would do is click install. Obviously, I already have mine installed, and so it's showing me disable and uninstall. But install this extension. It may require that you restart VS Code, and then we'll be ready to actually write some Go code. Okay, so let's go back to the file view, which is right here. And I'm going to click F11 on my keyboard. I'm on Windows, which is going to make this full screen. So whenever we're writing Go code, the very first thing that we need to do is we need to define what package this code is inside of. Now, for now, you don't really have to worry about what this means. Just write this line and leave this at the top of your file. Otherwise, you will get an error. So I'm just going to say package main. Again, I can't really explain this to you because it's pretty complicated and it has nothing to do with what we're about to write, but this is required at the top of all of your Go files. You write package and then the name of the package that this Go code is going to be a part of. Essentially, packages are directories that contain a bunch of Go files, and these Go files are called modules, and you can use multiple Go files within one program. That's way too advanced for us to look at right now. For now, just understand package main is kind of a required line at the top of your program. Okay, so now that we have package main, what I'm going to do is import a library that we're going to use here to be able to output stuff to the console. So I'm going to say import, and then inside of double quotation marks, I'm going to say FMT. Now, this is something you're probably going to import in all of your Go programs. This allows you to actually output stuff to the console and to collect user input. Again, you don't have to worry about exactly what this is doing for now, but it just gives us access to some tools that are built into the standard Go library, again, to output stuff and to actually collect user input. All right, now after we have this, we're going to write the following line, and I'll break down what this is. So we're going to write func. What this is doing is defining a function. Again, you don't have to understand what a function is. We're then going to write main. Make sure the name is main here. If it's not main, you're going to mess up your program. Then you want to have an opening parenthesis and closing parenthesis, and an opening curly brace and a closing curly brace. Now, this is the entry point for our code. All of the stuff that we want to execute when we run this Go file, we're going to put directly inside of this function. Now, you don't really need to know what the function is, but it's pretty much an executable block of code. And by naming this function main, this makes it the entry point of our program. So this will automatically be run, everything inside of the curly braces here, when we run our Go code. So for now, I'm going to show you how we can print out hello world to the screen. Then I'm going to show you how to run and build this Go code. And then we'll talk more about what all of this stuff is doing. So I'm going to say FMT inside of here, .println, this stands for print line. Make sure you get the capitalization correct because that's important. And then inside of double quotation marks, I'm going to say hello world, exclamation point, because this is our first Go program. So we're always going to print out hello world whenever we're writing our first program. Anyways, fmt.println, hello world. What's going to happen when we run this Go code is this is simply going to be outputted to the screen so that we know something is actually happening. Great, we have officially written our first Go program. So now I'm going to save the file, and I'm going to show you how we can run this code. So what we need to do here is we need to open up our terminal or our command prompt. So I'm going to drag from the bottom of the screen here, and notice that I have a terminal open. Now, if you are not using Visual Studio Code, you're just going to have to open up a terminal if you're on Mac or Linux, or open up your command prompt if you're on Windows. Now, inside of here, you should be able to run the command go. So I'm going to click go, or I'm going to type in go and hit enter, and we should see that something is being outputted. Now, if for some reason this go command is not working, you may have messed up your installation of go, or you may need to restart VS Code or restart your terminal or command prompt and then try running the command again. All right, so at this point in time, I'm going to assume that your go command is working, and now I can show you how to run this file. First, though, I will mention that Go is a compiled language. Now, what that means is that what we have in front of us right here can't actually be executed by our computer. We first need to translate this into a lower level language, specifically an executable binary file that our computer can understand and run. So that means that we need to run this through a compiler. Now, a compiler, again, is just going to take this source code. The source code is the code that we've written here, translate it into another language, and then that language, or that new file that we're going to get, can actually be ran directly by our computer. Now, this is great because this means if you don't have Go installed on your computer, but you have access to a compiled Go file, you can still run this program. So unlike languages like Python, we don't need to have Python installed to be able to run Python code, assuming that in this situation here, the Go code has already been compiled. Anyways, I want to show you how to run this. I apologize for all of the explanations. So let's just go into our command prompt or into our terminal, and let's run the following command, which is go run, and then the name of the file that we want to run. So notice the directory of my command prompt is in the folder where my Go file is. If you're using VS Code and you open up the terminal, it will just be here by default. And what I'm going to do is go run and the name of my file. Now, when I do this, it's going to take a second, and we're going to see that we get the output hello world. Awesome. There we go. We have just ran our first Go program. So what this command actually did for us is it compiled this code into the executable binary code. It then ran that executable binary and then immediately deleted that after the output of our code was given to us, because we used the go run command instead of another command that I'm going to show you, which is the go build command. Now, a lot of times what you want to do is you want to take all of your Go code, you want to package it up into that executable file, and then you want to give that executable file to someone else or allow someone to run it. So if that's the case, you can actually compile this code manually without running it, and you'll be given that executable file. So let me show you what I mean. If I type go build and then the name of my file, so in this case tutorial.go, you're going to see that it's actually going to give me a .exe file inside of the directory where I ran this command. Now, if you're on Linux or Mac, you're going to get a slightly different file. The extension is going to be dependent on the operating system, but in this case, I now have a Windows executable Go file. And the way that I can run this file is I can double click it if I was in my file explorer, or I can just type the name of it. So I can type tutorial.exe, hit enter, and then it's going to run this code. And this will work regardless of if I have Go installed on my system or not. Now, if you're on Mac or Linux, the way you're going to run this executable file is you're just going to type / and then the name of the file, which most likely will be tutorial or whatever the name of your Go original file was. So in this case, mine was tutorial.go, so I get tutorial.exe, or if I was on Mac or Linux, I just get tutorial, but if you named it like hello, then you would get hello.exe or whatever hello and no file extension. Anyways, Mac and Linux just do / in the terminal, and then you can run it. You also should just be able to double click that file, and it should run as well. Okay, great. So I'm just going to clear my terminal here and move this down to the bottom of the screen. Now that we understand how to run our Go code, we have our environment set up, and we've looked at our hello world program, I can start talking to you about some more interesting things in Go. All right, so now that we've gone through all of that, I want to start by discussing the project that we're going to work on and then actually starting to build the project. So the project we're going to work on is a quiz game. Now that means we're going to write a program that asks the user a bunch of questions, takes in the answer of those questions, tells the user if they got it correct or incorrect, and then how many questions they got correct at the end of the quiz, as well as like their percentage. So if they got 85%, we're going to print that out. Anyways, this is going to be a really good beginner project and teach you a ton of different basic Golang concepts. Okay, so for our quiz game, the first thing I want to do is probably welcome the user to the quiz game. I probably want to say, hey, welcome to the whatever type of quiz it's going to be, and then maybe I want to ask the user for their name and greet the user to the game. Okay, maybe that's something that we want to do. So I'm going to start here by just printing out welcome to my quiz game. Now feel free to make these as custom as you would like, all of the strings that you're printing out. In this case, I'm just making them simple to save time in the tutorial. Okay, so there we go, pretty straightforward. We now are printing a new line. That's what println stands for, and this is what we're going to print. Now, before we can move any further, I need to talk to you about variables and data types. So a lot of times when we're writing code, we want to store something in a variable. Now, a variable is really just a container that allows us to store a value or some type of data inside of it. So since Golang is a strongly and statically typed language, that means when we declare a variable, we actually need to define the type of data that this variable is going to hold, which is going to lead me to data types in 1 second. For now, though, I'm going to show you how we make a variable, which is pretty easy. We do something like var. We then give the variable a name. So maybe I call this variable actually name, and then we declare the type that this variable is going to hold. Now, in this case, I'm going to say string, and I'm just going to make it equal to Tim, but I'll discuss what this means. So what I've done is I've just made a variable. The variable is called name. It has a type of string, and I've assigned it the value of Tim. That means if I were to print out the variable name, it would print out Tim because name is storing Tim. Pretty straightforward, but that's what variables do. They store values for us, and we can then access those values or change the values of variables later in our program. All right, but let's talk about what this is right here, because this is the data type of this variable, and this is very important in Golang. So a string is the first data type that we'll look at, and really it's anything that's surrounded in double quotation marks. So a string is really a sequence of characters. This here is a string, right? Welcome to my quiz game, that's a string. Something like Tim, that's a string. Something like 1, 2, 3 instead of double quotation marks, that would be a string. Something like underscore hello world, that's a string. Again, anything wrapped in double quotation marks is going to be a string. Okay, so that's our first data type, pretty straightforward. Now, other than a string, we have ints. Now, an int is simply any whole number. So something like 21, something like -9, something like 1000. All of these are ints, otherwise known as integers. Great. Other than that, we have uint. Now, a uint stands for an unsigned integer. This simply means any positive whole number. Now, 0 is included as well, but really when we have a uint, an unsigned int, we just can't have something like -9 or -2 or -3. That's invalid because this here is the sign, which is negative, and well, you can't have that on an unsigned integer. Okay, great. Now, other than that, we have a float. Now, I actually have to do float 64. I'll discuss what this is in a second, but float is really any floating point value, any value that has a decimal in it. So if I have something like 2.0, this is a float because we have 0.0, that's the decimal part of the number, the floating point part, right? If I do something like 2.1, again, that's a float. If I do something like -92.3, that's a float because we have a decimal in it. Doesn't matter if it's something like .0 or .00000, whatever. It's just if you have a decimal, that is going to be a float. Now, the reason why I needed to add a 64 here is because when you define a float, you need to pick the precision for this float. Now, I don't want to talk about this too much, but putting a 64 here says that we're going to use 64 bits of our computer's memory to store this float. So don't worry about that too much, but just understand that when you do define a float, you need to specify the precision or the number of bits that are going to be used to store the float. And by default, we're just going to go with float 64. Now, we also have the option to use something like float 32, but float 64 is what we'll go with for right now. Again, don't worry about that too much. A float is just anything that has our floating point decimal number. Okay, awesome. And just to mention here, something like -2.8, that's totally fine. A negative value that has the floating point is still a float. All right, so now we have covered uint, int, float, string, and we need to talk about bool. Now, a bool stands for Boolean, and this is one of two values, either true or false, okay? That's the only two things that we can store in a Boolean value, or in a Boolean type, sorry, true or false. Great, we have now gone through the core data types in Golang. Now, there's a few other data types as well, but they're not going to be covered in this tutorial because this is meant for beginners. All right, so now that we've done that, let's just declare our name type again. So we're going to say var name string is equal to Tim. There we go. We now define the string data type that stores the value Tim. Now, the reason why this is important here, why we need to put the type of this variable, is because once we define this variable name as type string, we can't store anything inside of this variable that's not a string. So I could theoretically do something like name is equal to Joe. This is fine. What I'm doing is I'm changing the value of name now to store Joe, but I can't do something like name equals 23. The reason I can't do that is because 23 is an int, and an int is not a string, and I cannot change the type of this variable once it's defined. So actually, I want to demo this to you. So if I go here and I type in go run and then tutorial.go, you're going to see that we get an error. It says cannot use 23, type untyped int as type string in assignment. Again, because 23 is not a string, so we can't assign that to the string variable. All right, hopefully that makes sense. Now I'll just show you that if I do something like hello, and I run this, we're actually going to get an error, but the error is going to be different than we expected. So if I do this now, it says name declared but not used. So what this is telling me is that it was fine for me to assign hello to the variable name because hello is a string, but since I didn't use the variable name, I'm getting an error. Now this error is pretty unique to Go, but in Go, whenever you declare a variable, you need to use that variable somewhere. You need to actually access the value of it. Otherwise you get an error, because if you don't use the variable, what's the point of having it in your program? Go is going to yell at you and say, hey, you need to actually use the variable. Otherwise there's no point in having it defined. So what that really means is that I need to do something like fmt.println, and then I can just print out the name directly. And now since I'm actually using this name, you'll see that when I save the code and I run it, we no longer get an error, and it's going to print out the value of the variable name. Okay, hopefully that makes sense. We've just really quickly covered variables. Now the thing is, in Go, they realized that it can be really annoying to have to define the type of every single variable that you make. And sometimes it's not so easy to actually pick what this type is. It could be very complicated. So that's why they have another way to define variables that implicitly defines the type for you. So this is the following syntax. Name equals, and then something like, let's actually just go with a legit name, which is Tim. So this syntax right here, the colon and the equal sign, is actually going to implicitly guess what the type of this value is right here, and then assign that as the type for this variable. So this is the exact same thing as doing var name string equals Tim, except now we don't need to manually declare that this is a string. Instead, Golang will actually do this for us. It will look at this value. It will determine that this value is a string because it knows what a string looks like, and then it will just manually make the type of name equal to string rather than requiring us to do that. Now, we also don't need the var keyword because we're doing it in this format. Hopefully that makes sense, but this is kind of the shorthand notation, and this is actually what's recommended in Golang to define variables to make your life easier. So just to show you that I'm not lying, if I run the code here, we'll see that we get the same thing as we did before, and we're not getting any errors because this type is now string. It's implicitly guessing that and doing that for us. All right, so now that we've gone through that, I want to talk about some more advanced ways to print stuff out to the console, because right now we've just been using println, which just is going to print something, and then it's going to put whatever we print next on the next line, right? That's why you see that we have this kind of empty line at the end of the program, because it's printing something, and then it's going to print what's called a new line character, which will move the cursor of the console down one line, so the next thing that we print happens on the next line. Anyways, let's look at how we would print something out like, hello, Tim, how are you doing? Now, I want to use whatever is stored inside of name. In this case, I have Tim inside of name, and I want to print out hello, whatever the name is in this variable, and then how are you doing? So how would I do that? Well, there's a few ways that we can go about doing this, but the way I want to show you is using something called printf. Now, printf allows us to actually embed variables and expressions directly inside of what we're going to be outputting. So let me just show you an example, and then you'll see what I mean. So I'm going to say hello. I'm going to say %v, comma, and then how are you doing, question mark. Now notice %v is actually being highlighted in purple. That's because this is a special character that's actually going to take the value of whatever the next argument is that we pass to this printf function. Now this here is known as a function. What it's going to do is it's going to take in some arguments. Arguments are the things that we're passing to the function, so this string right here, as well as this name. Now when I do something like %v, this is saying, okay, this is a placeholder for the value of whatever the variable is that you put to the right-hand side here. So since I'm passing name and I have %v, now name, whatever the value of it is, in this case Tim, is going to be replaced with %v, and we're going to print out hello, Tim, how are you doing? So let me show you what I mean. Let's go run tutorial.go. And notice we get hello, Tim, comma, how are you doing? Nice. Now let's change this to something like Joe. Okay, and let's run the code here. And we get hello, Joe, how are you doing? Now, %v is just one of the many placeholders that you can use, and I'll show you that you can use multiple placeholders in one expression here. So let's say I wanted to print out Tim like 5 times or something, or let's just go with 2 times. Then I could add another %v here, and I would just have to put another variable on the right-hand side of this printf, so that I'm saying, okay, name is going to replace this, and then name is going to replace this as well. So let me show you this. I'm going to go run tutorial.go, and I get hello, Joe. Joe, how are you doing? Hopefully that makes sense. Now let's make a new variable. So let's say something like number, or actually let's do something like age, colon equals, and then let's go with 21. That's my age. And I will say hello, and then whatever the name of the user is, and then I will just tell them what their age is. So I'll say you are, and then we'll go with %, and not age, sorry, %v, like that. And now I can say name, and I can say age. Okay, so let me now run this. And we see, welcome to my quiz game. Hello, Joe, you are 21. And then I really don't need a question mark there. I could put something like an exclamation point. Okay, hopefully that makes sense. %v is kind of the main thing you're going to use here in terms of replacing variables inside of this string. However, there is a few other ones like %d. This stands for decimal notation. This is used to print out numbers. We also have %f. This is used for floating point numbers. There's a bunch of other ones. I'm not really going to go through them, but I will leave a link here. Let me actually just copy this into my browser and show you that kind of goes through all of the formatting options that we have. So this I will leave in the description. Go by example, string formatting. So when we type printf, that's saying print with formatting. You can use all of the different things inside of here to kind of print out numbers and values with different formatting options. Okay. All right, so now we understand how we can print out variables and kind of embed them inside of strings. What I want to do next is I want to get some user input because our program is pretty boring if we're not allowing the user to type anything in. So I want to immediately ask the user as soon as they run our program what their name is. So then I can greet them and I can actually start running the quiz game. So how are we going to do that? Well, let's get rid of these 3 lines right here and let me make a variable. Now I'm going to say var name, and I'm going to make this of type string. But notice I'm not actually going to assign it a value. I'm not going to do equals and then something like hello. Now I could do that, but I'm not going to. Now when I don't do that, what's happening is I'm saying, okay, I want to declare a variable called name, but I don't want to give it an initial value. Now I'm going to define that it's type string, but right now it's just going to be holding an empty string. It's not going to be holding anything because I haven't given it a value. That's completely fine. A lot of times you want to do that. Now you don't just have to do this with strings. You can do this with ints, with bools as well. So I can do var, and let's just go test, bool, like that. Completely fine. I don't need to give it an initial value. Okay, hopefully that makes sense. I'm kind of just putting the placeholder here and saying, all right, I want to declare a name. It's going to be string, and I'll give it a value later on. Now, though, I want to show you how we collect user input. So what I'm going to do is say fmt.scan. Now, .scan allows me to actually scan something into my program. So it allows me to let the user type in the console, and then whatever they type, it's going to give it to me and store it in a variable. So if I do something like fmt.scan, and then I put an ampersand and I put name, what's actually going to happen is I'm going to store whatever the user typed in the name variable. Now the ampersand is a little bit confusing. We'll get to that in a second, but for now, let me just show you that this works by going here and saying fmt.println, and we'll just print out the name for right now. Okay, so we'll go through this in a second, but let's go to our console. If I can bring this up here, let's type in CLS and let's run this. Now notice it says welcome to my quiz game, and my cursor is right here in the console. So I can actually start typing. I can say something like Tim, and when I hit enter, it's going to print that out, right? Because it's storing whatever I type in the variable name, and then I'm accessing the variable name and printing that out. Okay, hopefully that is clear. So let's talk about what this ampersand does. Now this ampersand is a little bit beyond this tutorial, but I do need to show it because we have to use it here. What this does is actually reference the memory address location of this variable. So to go on a quick tangent here, every single variable in our program is going to be stored somewhere in our computer's RAM. RAM is random access memory. That's what our computer uses when it's running programs. Now in this case, name is going to be stored at some random location in RAM. We don't really care or know what that location is, but to access it, we use this ampersand. Now the reason we need to do this is because fmt.scan requires the memory location to assign the value of this variable equal to whatever it is that's typed in. Hopefully that kind of makes sense. It's kind of annoying that you can't just do something like name, but it requires that you pass in the ampersand, which gives what's known as a reference to this variable, which scan will use to set the variable equal to, in this case, whatever string the user types in. Again, you don't need to worry about this too much. Just understand that when you're using scan, you need to put an ampersand and then the variable that you want to actually store the value the user types in. Now, one thing to note here is that you can also scan integers, you can scan floats, you can scan booleans. It doesn't just have to be strings. So I can do something like var. Let's go with age, and then we can say int right here. And now if I go fmt.scan and I just go with int, let me just get rid of name right now. And sorry, not int, I go with age. And then I print out age. Now I'm going to be able to actually type in a number and have that number come in as an integer and be stored in the variable age, as opposed to getting the string data type. So let's run this now. Let's save and run. And notice that I'm going to type in 21 and it prints out 21. However, let's see what happens if I do something like hello. When I do that, notice we get 0. Now that's a little bit weird, but the reason we got 0 is because hello was not a valid integer, and we can't store hello inside of a variable that is of type int. So it just gives us the default value of this int, which is going to be 0. All right, so hopefully that makes a little bit of sense, but the type that you have for your variable really matters, and whatever that type is, that's what you're going to have after you do this scan, right? So if I type in 21 and I have my variable of type int, it's going to give it to me as an int. But if I have this as type string, it's going to give it to me as a string. Okay, so now that we understand that, let's go back to the name example, and then let's get the user's name and greet them, and then start asking them some questions. So I'm going to say var name, and this will just be a string. And then I'm going to say fmt.scan, and I'm going to say that this is equal to, if I could type properly here, which I'm having trouble with, ampersand, and then this is going to be name. Okay, so now we're scanning this into the name variable, and now I want to greet the user. So I'm going to say fmt.printf, and I'm going to say hello, comma, we're going to go with %v like that, welcome to the game. Okay, and then we'll go comma, and then name like that. Okay, great. So let's run the code. Go run tutorial.go. Welcome to my quiz game. Notice it's asking me to type something in, so I'm going to type in Tim, and then it says, hello, Tim, welcome to the game. Great. However, one thing I want to do here is I actually want to have a prompt that tells the user to enter their name, because right now it doesn't really say anything, and it's kind of confusing for the user. So what I'm going to do is right before I actually have this scan here, I'm going to say fmt.printf like this, and I'm just going to say enter your name, colon like that. So let's see what happens now when I do that. Okay, go run tutorial.go. Let's go with Tim, and then it says, hello, Tim, welcome to the game. Awesome, that is much better. Now notice here that I used printf instead of println. Now println is going to make it so that we move down to the next line after we print this. If I don't use println, I use printf instead, you're going to see here that what happens is it says enter your name on the same line. Now, obviously we don't want that. Let me just get out of this here. That's why I'm using println. Now, if you're using printf and you want to make it go down to the next line after you're printing the formatted string, what you can do is embed this special character called \n. Now, this is known as the new line character, and what it does is it moves the console down to the next line. So just to show you something here, if I do something like enter \n and then your name, you're going to see it's going to print enter, it's going to move us to the next line, and then it's going to print your name and then allow us to type. So let's look at this. Let's go here and see it says, welcome to my quiz game, enter. It brings us down to the next line, your name, Tim, and then the rest continues as we would expect. Okay, hopefully that makes sense. I just wanted to cover that. All right, so at this point, we've made a little bit of progress on our game, but I want to continue and actually start asking the user some questions. So the first question that I want to ask the user is for their age, and I want to determine if they're old enough to play my game. Maybe I'm going to make the age limit or the age minimum something like 10 years old. Maybe I have, explicit content in my game, whatever. This is just going to be a good first example to go through. So now we're going to repeat the process. I'm going to say fmt.printf. I'm going to say enter your age, if we could type properly like that. Then I'm going to make a variable. I'm going to say var age int. Okay, now I could also make this an unsigned integer if I want, so that they can't type in a negative value. In fact, let's do that. That's going to be good. And then I'm going to say fmt.scan, and I'm just going to scan into the ampersand age variable. Okay, now what I want to do though is I want to print out something that tells the user if they're old enough to play. So this is where we're going to start talking about conditions. So I'm just going to do this, and then I'll talk about how this works. So I'm going to say fmt.println, and I'm going to say age is greater than or equal to 10. So maybe the minimum age to play is going to be 10 years old. Now, what I've just done here is I've written a condition. Now, a condition is anything that evaluates to true or false. So in this case, what's going to happen is age is going to be compared to 10, and we're going to check if age is greater than or equal to 10. Now, remember that true or false is the Boolean data type, which means a condition is anything that evaluates to bool. So what this does is this gives us the value true if this condition is true, so if age is greater than or equal to 10, or it gives us false if age is not greater than or equal to 10. So now I'll just print this out, and it's going to tell us whether or not the user is old enough to play or not old enough to play by printing true or by printing false. So let's run our code. Go run tutorial.go. Let's enter our name of Tim, and hello Tim, welcome to the game. It says enter your age. We're going to have to fix this because it's on the same line. Now I'm going to enter 9, and notice it prints out false. Now let's just run this again. Let's type in our name of Tim. Let's type in our age. Let's go with the real age now, and notice it prints out true because we were greater than or equal to 10. Okay, now just like we have greater than or equal to, we have greater than. Now if I were to type in 10, this would evaluate to false because this is checking if age is strictly greater than 10, not greater than or equal to. Of course, we have less than or equal to. We have two equal signs, which is checking is the age exactly equal to 10. And we have the not equal to, which is telling us is the age not equal to 10. Pretty straightforward, but those are our conditional operators, and all of these allow us to get something that is true or false. Okay, so let's just fix this so it's not showing up on the same line. The way I'm going to fix that is I'm going to add a \n here. The reason I need to do this rather than changing this to ln is because if I change that to ln, then I'm no longer able to actually print out my formatted string, okay? So that's why I need to do the manual \n, which now means that this will go on a new line. Now I also could do this. Just put a \n at the beginning of this line. Doesn't really matter. It's kind of up to you. Okay, so let's go \n here. Okay, so now that we have gotten this and we understand the condition, what I would like to do is I want to print something out if the user is old enough to play or if they're not old enough to play, right? So if they're old enough to play, I want to start asking them questions. If they're not old enough to play, then I want to immediately end the program. So this is where we're going to start talking about conditionals, really if and else statements. So I'm just going to write one out because they're pretty straightforward. But I'm going to say if the age is greater than or equal to 10, then I'm going to say fmt.println. I'm going to say, yay, you can play, ! Okay. Now take a wild guess at what this is going to do. I'm going to run the code and then we'll explain it. So here we go. It's going to ask me for my name. I'm going to say Tim. It's going to say, hello, Tim. Welcome to the game. I'm going to enter my age of 20. It's going to say, yay, you can play. Now let's run this again. Let's go Tim. Let's enter the age of 9. And then notice it doesn't print anything out. So what we just did here is we wrote what's known as a conditional block. This is pretty much saying we're only going to run what's inside of these curly braces if what we've written here is true. So this is a condition. This is something that evaluates to true or false, which is our Boolean data type. And if this is true, we're going to run this line. If it's false, we're not going to run this line. So here we're checking if age is greater than or equal to 10. So if we type anything 10 or greater, then we'll run this. Otherwise, we won't. There you go. You've just learned how to implement an if statement. These are pretty straightforward, but very, very powerful. All right. So now that we've printed something if they can play, I want to print something if they can't play. Now, one thing that I could do is I could say if age is, let's go with less than 10, then I could fmt.println, you can't play, ! However, this isn't the most efficient way to do this because we have something known as an else statement. So first of all, I just want to mention this is valid. This is going to work the way that we would expect. We're going to check this if statement, then we're going to check this if statement, and one of these will end up running because it's either going to be greater than or equal to 10 or it's going to be less than 10. But since we know that if it's greater than or equal to 10, it can't not be greater than or equal to 10, there's no point in us really running this if statement down here. It's kind of redundant, if that makes sense at all. So this is where I'm going to introduce something called the else statement. Now, the else statement is exactly what it sounds like. It's what's going to happen if this if statement does not run. So I'm just going to say you cannot play, exclamation point. So the idea here is we're going to check this condition. If it's true, we're going to run this. If it's not true, so else, we're going to run this. So this is saying, okay, we're going to try to do this. If we can't do it, we'll do this one. So one of these two blocks is going to run. Either the if block or the else block is going to run, okay? Let's go ahead and run this. So I'm going to go here and go run tutorial.go, enter the name of Tim. Let's enter the age of 9. And now it says you cannot play. Let's run again. Let's go Tim. Let's enter 10. And now it says you can play, right? Perfect. Okay, so let's clear that. All right, so you have now learned about if and else's. Now, this is really all we need to start implementing the quiz game. So let's now ask our first question, but only if the user is allowed to play. Now, the way that I'm actually going to make it so that we won't ask the user a question if they're not old enough to play is I'm going to write a line right here called return. Now, this is a little bit complicated for this tutorial, but what this is going to do is it's actually going to break out of this main function. So whenever you see a return keyword, this actually allows you to return a value from a function. But since we're not dealing with functions, for now, what you can think that this is going to do is it's just going to immediately end our program. So we're inside of this function main. And as soon as we hit a return keyword, we exit the function, which means that if I put a line like here, like fmt.println continue, we're not going to get to this continue line if a return statement is occurring before. So if we hit this return statement, which means we were in the else statement, then we won't print this out. But if we don't hit the return, so if we were old enough to play, then we'll continue. Hopefully that makes sense, but let me run this and show you an example. Okay, so go run tutorial.go. Let's type in our name of Tim, and let's go with 20. And then it says, yay, you can play and continue. Now, if we do this in the other case, so I say Tim, and I enter something like 8, then it's going to say you cannot play. And notice we didn't print continue. All right, so now let's continue and actually ask the user some questions once we get to this line. So we can go ahead and do this. I'm going to say fmt.print, if I could type properly here, printf. And we're going to start by just asking whatever the first question in our quiz is going to be. Now, you can make this whatever you want. For now, I'm going to say, what is better, the RTX, and then we'll go with 3080, or RTX 3090 question mark. Now, these are graphics cards. And one thing I want to note is that I'm intentionally using printf, and I'm adding a space at the end here because I want the user to start typing at the end of this line. If I were to type println, then that would mean the user would start typing on the next line, not after the question mark here. Okay, so that's why I'm using printf. Anyways, now I'm going to say var answer, and then this will be a string, is going to be equal to, actually, I don't even need to give it equal to anything. I'll just write it like that. And I'll say fmt.scan, ampersand, and then answer. And for now, I just want to go with fmt.print, and we can just print line, and I'll just print out the answer, okay? Before we actually check what the answer is. So I'm going to run my code, go run tutorial.go. Okay, enter your name, Tim, age 21. Yay, you can play. What is better, RTX 3080 or 3090? Let's go RTX and then 3080 and hit enter. Now notice that the answer that it printed out here is RTX, not RTX 3080, even though I typed in RTX 3080. Now that's actually the incorrect answer, but either way, notice how it's not giving me the 3080. Now this is something that I need to cover, which is kind of a potential problem with this scan, statement, scan function, whatever you want to call it. So the thing is, this scan function, what it actually does is it scans space-separated values in your input. So what that means is it's going to store whatever the first value is that I type in that's not separated by a space in one variable, And then the next thing that I type in separated by a space, it will store in another variable. So here it's only giving me RTX because I only gave it one variable to scan the values into. So I have RTX, it's storing RTX, but then the 3080 would need to be stored in a separate variable because that's how this works. So hopefully that makes sense, but as soon as you hit a space, it's going to kind of stop storing that current word or that current input, and then it's going to move on to the next one and try to store that in a second variable. So let me show you what I mean here. If I go var answer2 string, and then I go here and I go ampersand, and we go answer2. Now if I print answer and then answer2, let's run this. And notice that after I get past these, I can type something like RTX 3090, and now I get RTX and 3090. So RTX is an answer, and 3090 is an answer too. So this is a potential solution to be able to collect both of these values, is to store them in two separate variables, and then we're going to have to combine these variables together by performing a concatenation to actually compare this against what we think the correct answer should be. Okay. Hopefully that makes sense. Now there's other ways to actually collect the entire line, but I don't want to show them because they're too complicated for this tutorial. So for now, if you want to collect multiple words, this is going to be the solution that you're going to have to use, okay? Declare multiple variables, put multiple values inside of here, multiple variables, right? And then it's going to scan all of those words in. Now let's look at something else here. If I run this and I go Tim 21, and let's just type RTX. When I hit enter, notice that the program's not ending. Now, the reason it's not ending is because it's waiting for me to type the second word. So it's not going to end until I type two things. So keep that in mind when you're using this scan. If I put two variables here, it's going to wait for me to type two individual values before it moves on to the next line. So now if I type 3090, that's fine. But again, I need to type two things in because I'm accepting two things inside of fmt.scan. Okay, I think that's all I need to cover for the scan. Now we'll go with answer and answer2 for now, that's fine. And then what I want to do is I want to check if the answer that the user typed in is equal to the correct answer and tell them if they got the question correct. So I'm going to say if, and then I'm just going to go answer plus answer2, I'll talk about what this is doing in a second, is equal to RTX 3090. Then I want to fmt.println, and then correct exclamation point. Otherwise, I want to say fmt.println and then incorrect exclamation point. Okay, so what answer plus answer2 is going to do is it's going to add these two strings together. So whenever we have multiple strings, we can concatenate them. That means to join them together by just adding them using the addition sign. So since the first part of my answer is stored in answer, and the second part is inside of answer2, then I'm going to combine them, right? So I'm going to say RTX plus 3090. However, when I do this, it's going to give me the string that looks like this, RTX 3090. Now that is not equal to RTX space 3090, right? Whenever we have a space, that's going to make the string different. RTX 3090 no space and RTX 3090 with a space are different strings. Now, same thing like this, right? Even if I had this, these are different strings because this is a lowercase x. That's just worth mentioning. Anyways, though, this means that I want to add a space in between here. So I'm going to do that. So now I'm going to combine the two answers with a space and then see if that's equal to RTX 3090, which is the correct answer. Okay, so let me run this here. Let's go run tutorial.go. Let's go Tim 21 and then RTX 3090, and it gives us correct. Yay, there we go. We now know how to collect multiple words from user input. Now let's try this again, and let's type in Tim and then 21, and then let's go with something like RTX 3080, and notice that we get incorrect, right? And if we were to type anything other than RTX 3090, then it would not give us correct, it would give us incorrect. Okay, let's clear. Perfect. Now let's say that maybe there's a second correct answer to this question. Maybe they can type in RTX 3090 using all lowercases for the RTX. Because right now that's not going to work. Well, how would we make that answer correct as well? Well, the way we do that is by now implementing an else if statement. So let me show you how this works. You write else if, and now you can check another condition here and check if this condition is true. So let's do this. I'm going to say else if, answer plus answer2 equals RTX 3090, but I'm going to now this time make this lowercase RTX. And then what I'm going to do here is I am going to say fmt.println and then correct exclamation point. So let me just describe what I did. So now we've implemented the elif statement. So we're checking if this condition is correct. Now, if this is true, answer plus space plus answer2 is equal to RTX 3090, we're going to print correct, and we're just going to move down to the end of the if statement. We're not going to do the else. We're not going to check the else if, and I mean, that kind of makes sense if you read what, else if is saying. Now, if this statement is false, so if this condition is false, then what we're going to do is we're going to go to this condition, so the else if condition below it, and check if this is true. So we're going to say if this is false, then we want to check this. So if answer plus answer2 is equal to RTX 3090 with the lowercase, then we'll print correct, and then we'll go down to the end of the if statement. Now, if this is false, then we'll go to the else statement, okay? So we're kind of going in order. We're first checking this. If it's false, we check this. If that's false, we do this. If this is true, we're done. We don't check either of these. We just move to the end of the if statement. Now, one thing that's worth mentioning here is that you can use multiple elif statements. So maybe I want to check another possible answer. I'm just going to copy this in here. I want to check else if the answer plus space plus answer2 is equal to, and then maybe I want an RT and then a capital X 3090, right? Well, that's fine. I can do that. Let me just fix this a little bit. And oops, okay, I'm messing all this stuff up, but you get the idea. Now what's going to happen is I'm going to check this. And if this is false, I'm going to check this. If this is false, I'm going to check this. And if that's false, I'm just going to do what's inside of here. Okay? Hopefully that makes sense. Now let's go back to what I had before because I just messed up my code pretty badly. And there we go. That's better. That's the cleaner if elif statement I want. So just to clarify here, you can have as many elif statements as you want or else if statements as you would like. However, they must come after an if statement. You need to start with an if statement. You can have as many else ifs as you want. Then you can end optionally with an else, but you don't need the else. So in this situation, I could remove the else. That's totally fine. This block of code will still work. All right. So let's go back to what I had before. And now let's run this code and check out the else if. Okay, so go run tutorial.go. Let's go Tim 21, and then let's go RT and actually just lowercase RTX 3090. And then notice it gives us correct because now this was false. So we checked this, it was true. We printed correct, and then we were done. Okay, hopefully that makes sense. So now that we have done this, I want to do my next question, right? So let's now implement our second question directly after this. I'm going to say fmt.printf. And now what question do we want to ask? Let's go with another computer question. So let's do something like how many cores does the Ryzen 9 3900X have ? Now the correct answer is 12. This is the CPU that I have. That's why I'm going with this, but I'm going to say var. And then actually I can't call this answer. And the reason I can't call this answer is because this variable already exists. So what I could do is I could just say fmt.scan &answer, and then this would store whatever I typed in the answer variable. But the problem is the input that I want here is going to be an int. I want a number. I don't want a string. So how do I fix this? Well, since the answer variable is already defined and it has the type string, I can no longer use this variable. So instead, I need to come up with another variable that I'm going to use to store the answer, okay? Now, I could actually still use answer, but again, what's going to happen is my answer is going to come in as the type string, which means I would then need to check if the user typed in the string 12, not the number 12, which is not something that I want to do. So I'm going to say fmt.scan, but before I can do that, I need to declare the variable that's going to hold the answer. So I'm going to say var, and let's just go with cores, and let's make this int. And then I'll say ampersand cores like that. Now, for experiment purposes, if you want, you can try doing this with regular answer and you'll see the problems that I was discussing. Okay, so I'm going to say fmt.scan at cores or ampersand cores, sorry. And now I'm just going to do a very similar thing to this where I check if the answer is equal to the correct answer. So I'm going to say if answer is equal to, in this case, 12, then what I can do is fmt.println and I can say correct ! Otherwise, I can fmt.println incorrect ! There you go. That's all I need. I don't need an else if because there's not really any other way to type 12 unless the user were to type in like 12, but that's not going to be accepted as an answer. We're just not going to accept that. Okay, so let's just test this out and see if this works. So let's go run tutorial.go, and we get a problem. It says invalid operation, answer equals 12, mismatch types, strings, and untyped int. This is actually a good problem to run into because I realized that I typed this variable wrong. But what this is saying is that I cannot compare a string and an unsigned integer, which is what I'm trying to do. Now, I didn't mean to type answer here. I meant to type cores because we want to check this, not this, but it's just worth noting that when you're going to be comparing different types, you usually can't do that. So I can't compare a string and an int here because how do I compare if a string is equal to an int when they are different data types? It's an invalid operation, and well, that's why I am getting an error, okay? Just worth noting. Now, one thing I will do is actually change this to uint as well for unsigned int because I don't want them to type in a negative number. Okay, so let's continue here. Let's go run tutorial.go. Enter name Tim. We're going to enter age 21. You can play. What is better? Let's go RTX 30 or 2080. Okay, incorrect. That's fine. How many cores does it have? Let's type in 12, and then we get correct. Awesome. There we go. We have answered the question correctly. Okay, so at this point in time, I'm not going to implement any more questions because you guys can do that on your own. They're just going to follow this same format here. What I will do though, is show you a few different ways to kind of format these if and else statements. And I also am going to show you how we can keep track of how many questions the user has gotten correct. So if I want to keep track of the number of correct questions, I need a variable that's going to store how many correct questions I have. So what I'm going to do is I'm going to make a variable. Let's do it actually right up here. I'm going to say var score, and then this is going to be an int, and I'll just make this equal to 0. Now, I don't need to type out all of this, though, because I'm just going to assign the value of 0. So instead, I'm going to say score colon equals 0. And now Golang is going to interpret that this is an integer. It's going to automatically, I guess, make this type an int. And so I don't need to type out var score int. I can just do it like this. The reason why I need to do the types here is because I'm not assigning these a value. I'm just declaring that they exist, and then I'm going to use them in the scanners. So I need to explicitly define the type. Anyways, we have score. Now I'm going to show you how we can modify this variable to add 1 to it whenever we get an answer correct. This is pretty straightforward, but inside of my if statement, I'm going to say score plus equals 1. Now, plus equals 1 is an operation you can use to add 1 to the existing value of score. So if score was equal to -1 and I did plus equals 1, it would make score equal to 0, right? If it's 0, it's going to make it equal to 1. It's just going to add 1 to it. Now, writing this is the exact same thing as doing the following. Score is equal to score plus 1. All I'm doing is saying, okay, what's the current value of score? Add 1 to it, and then assign that to the variable score. That's completely fine because I'm assigning another integer to the int type. Okay, there you go. Now let's just make this plus equals 1. Now, one other way that you can do this is you can also do plus plus. Now, plus plus stands for increment, and this is going to add 1 to score. So if you only want to add 1 to it, you can just do score plus plus. This is kind of a shortcut. However, if I wanted to add like 5, then I would do the plus equals because then I could add any number that I want. In this case, I would add 5. Now, one thing to note too is that I could add another variable here. So maybe I had a variable called increment. I could put that here, and then whatever the value of that is, I would add that to score. Okay, hopefully that makes sense. For now, we'll go with score plus plus because we just want to add 1. So that means in here, I need to do this as well because if I get it correct, I want to add 1. And then I'm going to go to here and go score plus plus. So now that I've incremented the score, I'm either going to have a score of 0, 1, or 2 at the end of my program. So let's go ahead and print out what the score is. I'm going to say fmt.printf. I'm going to say u, and then we'll go like this, scored. This is going to be %v out of, and then the number of questions that we have. I also want to store this in a variable. So let's go up here to score, and let's say num underscore questions colon equals, and then we'll just set the number of questions that we have, which in this case is 2. Okay, so I'm going to say you scored whatever out of whatever. Okay, and then we'll go comma, and we will go with score, and then num questions. Okay, so let's just test this out, and then we can add some more stuff. All right, so go run tutorial.go, enter name Tim, age 21. Yes, you can play. What is better, RTX 3080 or 3090? Let's go RTX 3090, okay. How many cores does Ryzen 9 3900X have? Let's go with 10. It says incorrect, you scored 1 out of 2. Awesome, there we go. So now to continue with this, let's calculate the actual percentage score that the user gets. So to do that, I'm going to do it in kind of a more verbose way just so that you understand. I'm going to make a variable. I'm going to say % colon equals, and then what I'm going to do is I'm going to take the score. I'm going to divide this, which is the /, that's division, by the number of questions, and then I'm going to multiply this by 100. Now, the multiplication is an asterisk, and what I can do is define my order of operations here by doing the following. So I can say I want to do the division first in parentheses, right? And then I'm going to multiply this all by 100, and that should give me the correct percent. Now, again, Golang is going to infer what the type of this is going to be, so I don't need to manually define that this is an int or a float or whatever it's going to be. So in this case, now I can say fmt dot, and let's actually just add a new line here so that this goes to the next line. And we're going to print actually f, and we'll say you scored colon, and then this will be %v. Let's find that. And then I'm actually going to put a % sign so that it will say you scored like 75% or 80% or whatever the percent is. And then we'll add a period, comma, and then we'll put %. Okay, so let's run the program now. So let's clear the console and run. Name Tim, age 21, RTX, like this, 3090. Okay, correct. How many cores does this have? Let's go with 9. Incorrect. You scored 1 out of 2. You scored 0%, and then it gives me missing. This is a little bit weird. Why am I getting that? So the reason why we're getting this error here is because of this %. When I actually want to embed a % sign inside of my printf, I need to do a double % because the % is being treated as a formatting character. And so when I just have 1, it's saying missing here because it's missing what's coming after the %. So if I do 2%, this actually means a literal % sign. And so now we shouldn't get that problem. So let's try this now. Okay, let's go Tim, 21. Let's just enter RTX 3090, 2090. Okay, let's go with 12. And then notice we get you scored 0%. That's a little bit weird. Why am I getting 0%? All right, so I had to make a cut there because I was just looking at exactly the problem that was occurring, but we were seeing that what we were getting for our percentage here was 0% when we know the correct % should have been 50. So how do we fix this, and why is this problem occurring? Well, the reason why we're getting this problem is because right now we're dividing two integers. We have an int divided by another int. Now, whenever you do an operation with two data types that are the same type, the result of that is going to be that same data type. So if I have an int and I'm dividing that by an int, I'm going to get an int, which means I'm going to get 0 here. Now, if the score and the number of questions are the same, I would get 1. But since this actually gives me 0.5, it's just going to be rounded down to 0. Now, it works a little bit more complicated than that, but the idea is if I have one int and I'm dividing another int, that operation can't return me a float. It has to give me an int. And so since I can't store something like 0.5, it just defaults to storing 0. So what I actually need to do here is I need to convert both of these types to floating point values, divide them by each other, and then multiply them by 100. And that will then give me a float type here for my percent. So I'm going to say float 64, and I'm going to surround that. I'm going to surround score and float 64, and then same with the number of questions. Now, the reason why I need to do both of these here is, again, because we need to have the same type on the left and the right-hand side of my arithmetic expression. Arithmetic is just math. So if I was adding these, same thing, I would need to do that so that I can actually get the correct type here. I know this is a little bit confusing, but float 64 is just going to convert this type to a float 64 data type. So now when I can divide my two floats, I can actually store a floating point result of 0.5. I can multiply that by 100. I don't need to convert this to a float because it can be interpreted as a float. 100 can be stored as a float, so this is fine. And that means that percent now should give me 50, and I should actually print out 50. Again, this is kind of getting into the weeds of Golang and some stuff I didn't really want to cover in this video, but I guess I have to show you because we want to do some basic math, and hopefully this gives you some insight into the typing system. Okay, let's run this though. Go run tutorial.go. Let's enter the name. Let's enter 21. Let's enter RTX 3090. Let's do this incorrectly. And then it says you scored 50%, meaning that our percentage calculation is now working properly. Okay. Hopefully that is clear, but there you go. We now have the percent. Awesome. Now that I've showed you that, I'm pretty much ready to wrap up the video. The last thing I want to show you is how we can simplify this right here. So rather than repeating the code in here, we actually have two conditions that allow this here to be true. So some of you may have seen this before, but we have operators in Golang known as the OR operator, the AND operator, and the NOT operator. Now these allow us to chain conditionals together. Now to explain these, I have to go through them one at a time, so I'm going to start with OR. So what OR does, or what OR is, I guess, is two pipes, okay? So two vertical lines, and this is going to give you true if what's on the left or the right-hand side of this operator is true. So for example, if I have true or false, this is going to return to me true. Now, if I have the other way around, so if I have false here or true, then take a guess at what we're going to get. Well, we're going to get true. So the OR is just looking to the left and to the right. If what's to the left and what's to the right evaluates to true or false. So if it's a condition, it's going to look at both of the conditions. And if either of the conditions are true, it's going to return true. Now, if both of the conditions are false, it's going to give me false. Okay, now let's look at AND. Now, AND is kind of the opposite of OR. AND is checking the left and the right-hand side and telling me if both the left and the right-hand side are true. So in this case, I have true and false. Well, that's going to give me false because no, true and false, they're not both true, so I get false. Now, if I have false and false, of course, I get false. If I have false and true, I get false. But if I have true and true, then I get false. Okay, that is AND. Then we have NOT. Now, what NOT does is simply negates the true or false. So what that means is if we have a not false, this is going to be true, right? Oops, let's do the arrow the correct way, like that. Now, if I have not true, if we can get the exclamation point, then this is going to give me false. Okay, so it just simply reverses true to false and false to true. It negates them. There you go. Those are what's known as the logical operators inside of Golang. Now, the point of me showing those to you is that we can simplify this if statement block right here by removing this else if here and simply combining two expressions or two conditions together in this if statement. So let me show you what I mean. I'm just going to copy this. I'm going to remove this else if, and now we're just going to have the if and the else. But I still want to check if you type in all lowercase RTX then 3090. I want to check if you type that in, and if you do, I still want to say that you got it correct. So I'm simply going to put the OR operator here, and then I'm just going to put my other condition. So I'm going to check now if this is true or if this is true. Hopefully that makes sense, but I'm just combining two conditions together. And now if both this or this are true, then I will return correct. So either this one or this one doesn't matter. And if both of them are false, then I will print incorrect, okay? Now, if I wanted to add another one here, I could get crazy and I could add another OR. That'd be totally fine. In fact, if I do this, now maybe I want to check RT and then capital X, right? That's fine. I can now have three ORs together. And if either of these three conditions are true, then I'm going to do what's inside of the if statement. Okay. Now, just to show you the other operator here, if I were to make this an AND, then this would never be true. The reason why this here would never be true is because I'm checking if answer plus space plus answer 2 is equal to RTX 3090 and if it's equal to this. Now, of course, these can't be equal to both of these things at the same time, so I would always get false. Now, you use AND when you want to check if both of the conditions are true, but of course, here we want to use OR. All right, you can mess around with those and experiment with them, but that is how they work. Okay, so now let's run the code, and let's try this. So I'm going to say Tim, let's go 21, let's go RTX 3090. Notice we get correct, that works fine. Let's type in 12, correct, you scored 2 out of 2, you scored 100%. Awesome. All right, so with that said, I think I'm going to end the video here. My goal here was to give you the basics. I did not anticipate this video was going to be as long as it is, but there was a ton of stuff that I needed to show you, and I couldn't really skip it, otherwise it was going to leave you guys confused. Regardless, I hope this helped you get an introduction to Golang and kind of bring you a project that you can get up and running with and learn the basics of the language. A reminder to check out programmingexpert.io. It'll be linked in the description. That is my platform in partnership with AlgoExpert to learn how to code and to become a software engineer as quickly as possible. Anyways, if you guys enjoyed this content, make sure to leave a like, subscribe to the channel, leave a comment with any Go content you want to see in the future, and I will see you in another YouTube video.